linear transformation. Linear transformation. Linear transformation. Let U and V be two vector space over the same field F. We are assuming two vector spaces U and V on the same field F. U and V are two vector spaces over the field F. We are assuming it. Now then, our relation or mapping, then a mapping T of U into V is called a linear transformation. Then a mapping T of U into V is called a linear transformation. So we have assumed U and V two vector spaces over the same field F, and now we are saying that a mapping T of U into V, a mapping T of U into V is a linear transformation. Is a linear transformation, but when it will be a linear transformation? The mapping T will be linear transformation if, and this linear transformation will be actually a linear transformation of U into V, because the mapping T transform U into V. So a linear transformation of U into V, linear transformation of U into V. Then a mapping T of U into V is called a linear transformation of U into V when the mapping T of U into V will be called a linear transformation of U into V if it satisfy two conditions. Firstly, if T alpha plus beta equals to T alpha plus T beta for all alpha beta belongs to U, and the second condition T A alpha equals to A T alpha for all A belongs to the field F and alpha belongs to U vector space. So the mapping T will be called a linear transformation of U into V if it satisfies two conditions, mainly one is this one and second one is this one. So if it satisfies these two conditions, the mapping, if the mapping satisfies these two conditions, so it will be called a linear transformation of u into v. Okay, so if we combine the condition 1 and condition 2, we get by combining above two conditions, we get we get t a alpha plus b beta. Here we get a new term b. Those a alpha beta are familiar from the above two. And here we get a new term b, which we will define later. Now a alpha plus b beta equals to a t alpha plus b t beta, and all a comma b belongs to the field F, and all alpha beta belongs to the vector space U. So if some mapping T satisfies this condition, it will be called a linear transformation. If T satisfies this condition, it will be called a linear transformation where where a b belongs to the field F and alpha beta belongs to the U, vector space U, and this vector space U is over the field F. The vector, the U vector space is vector space over the field F, and that A and B belongs to the field F, and that alpha beta belongs to the vector space U. If T, a mapping operating on A alpha plus B beta, returns the value A T of alpha plus B T of beta, where A B belongs to the field F and where alpha beta belongs to U, then this mapping will be called a linear transformation. One more important thing I forget to inform you. You might have seen the thumbnail and the first part of the video. It's shown that there was written linear transformation and one more term was written there. It was homomorphism, but I didn't speak anything about homomorphism. So what is homomorphism? So what is homomorphism? Homomorphism. What is homomorphism? That the linear transformation is also known as the name of homomorphism. It's not special anything, it's the linear transformation with another name, homomorphism. So the linear transformation has another name of homomorphism.